nice. What do we have? That's canonical today. Yep. This is my accountability library. So we're looking at classes today and just see if we can run through.
Just by using class fields. So let's talk a little bit about methods. Methods are something that lives on a class. So I'm going to grab this hunc method, and I'm going to just drop it right into the class. And here we're emitting a string where the number of O's in the hunc is determined by the argument you pass in. And here you can see we're able to create a new car. And c.hunc, take my word for it, it would return this particular string. But this is a method now. This looks a lot like typing a function, like the freestanding functions that we've been working with, right? The arguments are the same. Optional fields are the same if you wanted to do this, right? Methods are pretty easy, or pretty much a natural extension from typing functions. So there's something new that has arrived in JavaScript recently, which for me means like the last several years. Static fields. So I'm going to grab this. It's just another chunk of stuff we're going to add to car. I'm going to put it up here. I'm just going to sort these in the way I would sort it if I were doing this for real. Cool. So what just happened? Well, we have a static field called next serial number. And when we say it's a static field, let me just get these out of the way so I can squeeze something down here. Look at that. I can call next serial number on the car class itself, not an instance of the class, the car class itself. So this is what we mean by the static side of a class. It's where the constructor lives, not instance properties. This is a class field. And similarly, this is a class method. Generate next serial number, we could call that, and it would invoke next serial number plus plus. We just spent a lot of time talking about this, and in a class method, like what we're looking at here, this is of type of car. Not to be confused with down here. This is not being very useful to me. It's car in an instance. Car being the interface describing a car, right? See, there it is, car. Up here, type of car. Type of car represents the static side of the class. It's as if we're in there doing the following. Not new car, but just car. They're sort of just like things dangling off of the class itself. So that's what this is in a static field context. OK, we have a missing member field here, which I can go ahead and add real quick. So we'll just say serial number, and we'll say car.generate serial number. So this we would say is a class field, and this is a class field initializer. So you can think of it as we're processing this class, and we go down and we find that field, and we invoke generate serial number and assign whatever the return value is to serial number. You sure could go down here and say this.serial number equals car.generate serial number. In fact, it's equivalent to that. Generally, ordering doesn't matter. We'll look a little bit at ordering later, like when is this run? When are these things run? One has to be first, and we'll see later. But the main goal for me when I'm using field initializers like this is I want stuff out of the constructor. It's really nice to be able to look at this one line and say, OK, there's this thing. It's a serial number. It starts out with a value that comes from here. And of course, because this returns a number, we don't need an explicit type here. Here we do, because you kind of need to know what those fields are before we start dealing with this code. We need to know upfront what they will be. All right. And here, because we added, I think I got my example code here a little wrong. Oh, no, I have it right. So the thing that's been added to get label is a little hashtag with the serial number. And here we go. I'm just indicating that it's going to increment by 1 because we have that static field where we're holding the next serial number, and it keeps incrementing over and over. There's another static thing we can do called a static block. This is a very recent addition to TypeScript and to JavaScript. And here's what that looks like. A static block. So let's imagine that instead of just saying, I'm going to set my serial number equal to 100, what I want to do is make an API call to some endpoint that gets me some serial number data. And I want to say the starting serial number is whatever the API says. Like, it'll tell me where I last left off, and I'll start counting from there. So we would delete this for sure. And this code ends up initializing that field. Now, when is this code run? It's run very shortly after the car class declaration is processed. What that means is you don't have to create an instance in order for this to run. This is run before you create any instances. I mean, it's async here. So like I'll say the fetch is dispatched before any instances are created. This needs some sort of like readiness indicator where you would say like, don't create any cars until we have the serial numbers that we start with. But conceptually, this is sort of like class level setup stuff, similar to the way this is set up stuff for an instance. This could be set up stuff for the class itself, a static block. This is not something that you invoke specifically. It's just something that runs immediately after this class declaration here is kind of evaluated. And you eval this file, and the static block will run. And I think you can have more than one. You can have more than one. So you could have a couple. They're going to run from top to bottom. And you could comment on each of them to say, like, what's the purpose of this thing? A very special thing, but it's something that you could see with the static keyword, and it can live on a class as of very recent JavaScript and TypeScript versions.
Makes sense. How do class fields define TypeScript compared to regular JavaScript? What is the purpose of defining class fields up front in TypeScript? To import type safety for defining class fields up front. I'll go with to enforce type safety for object properties. That goes without saying it. What does a static field in TypeScript class represent? A private method for internal class operation, a method that can only be called once, a property belonging to the class itself, not the instance. This looks more like it. It's used without being invoked. Yes. When is a static block executed in TypeScript class? During object initialization, not really. When the first instance of the class is created, only when specific method is called immediately after the class declaration is processed, because it's static. What is the primary difference between a class method and a static method in TypeScript? Static method and what? Static methods are, top of my head, static methods are only available, can be invoked without first instantiating the class. Meanwhile, class methods can only be accessed when you use the new keyword. Static methods are only primitive, class methods are always primitive. Not the instance, yes, not the instance. What is the purpose of a class initializer in TypeScript? To define static methods automatically, to create private class variable. I would favor this for, to set initial value, before constructor execution. That makes more sense.
Let's add some more stuff here. So like we kind of have a problem. I don't like that I can just like edit the serial number on my car here. Like I go
access modifiers. That's what about static private and other stuff.
Sedan serial number equals -123. That seems bad. shouldn't be able to mess with serial numbers on these cars. So what we're going to do is we're going to make that serial number private, and we're going to define a getter for it. So here we go. So these are the new lines here. So what we have here, and I have to delete this line in a sec, but I just want to leave it for comparison's sake. What we have here is a new property that we're saying is private. Private means only instances of this class can view this field. If I created a subclass, I would not be able to see this field. It's only this class itself. Protected means subclasses can see it too, but the outside world cannot see it. Like just because you created a car and you have a variable called my car, that doesn't give you a right to access the serial number. So if I delete this or comment it out, great, I've got this private field, at least it's a TypeScript private field, still generating the serial number. And then I created this getter, which will let, for example, this work, but I won't be able in subclasses to do something like that. Like it's a read-only property. There's only a getter for it. So this is an example of us using access modifier keywords like private and protected to sort of store information with one level of access, private, and then expose it in a controlled way with another level of access, protected. So like we can store it, no one can see it, or no one can write to it or read to it, and then we can deliberately open up a door that lets subclasses read it, but the outside public cannot. So down here, like it's not accessible from the outside. You can create static, private, and protected fields as well. So we're going to use this to kind of lock down the serial number generation up here. Really, I'm just going to add the private keyword to both of these. And this is kind of interesting because we were thinking about private and protected as pertaining to instances of the class. The mental model still holds true with one caveat. If you think about like car as having this static side, like this stuff up here, and then there are instances, private and protected still behave the way you would expect. Meaning, in static areas of this class, I can access private static stuff. In this instance, I can access private instant stuff and private static stuff. That's what lets me have access to this function here. This is instant stuff that's happening here. There's no static keyword, right? I could same as in here, like I could do, or car, generate serial number, no problem. If I were to change these to protected, then subclasses on their static side could access it, as well as on their instance side. So really think about it as a two-dimensional thing. There's static and instance, and then there's private and protected. Private and protected relate to like only this class, none of its subclasses. And then protected opens it up to subclasses. And then there's one more, but it's implied, like you don't need an access modifier keyword for this. You could say public like this, but everything's public by default, unless you say otherwise.
Two quick questions. One, the underscore naming convention is just it's just a naming convention, correct?
It is a naming convention, but I've done it for a reason. And that is, we have to remember, TypeScript melts away at build time. It checks your code, and then it says, I'm done, good luck, I'm going home. So if you were at runtime, you would still see this field here. It doesn't actually prevent other code from accessing this field. Like if you were to open up a JavaScript console, and you were dealing with like a deployed website with this code in it, you would be able to see underscore serial number, and you'd be able to write to it as well. It's just sort of something to help keep you honest within your own code base. So leaving an underscore there is important to give you a clue if you're ever, looking at a log file or something like that, or you've attached a debugger to a running version of the app, and you're dealing with something in a console. Like you still want to leave yourself an indication that this is not supposed to be public. But it's just kind of a statement of intention, and it's sort of, the honesty policy in that it's designed to help you, don't defeat it. There are ways now of making fields actually private, which we will talk about later in this chapter that we're on right now. I see there's a question in the chat about hashtag fields. We will talk about that. That's exactly where we're headed.
And the other question was just about the implicit getter not needing a type because it could be inferred from the class property. Line 23 there.
Yeah, it's inferred from the return type here. So unfortunately, if we did this, I'm going to follow my own advice. Do that. Yeah, return types are inferred. It's a good idea to add the return type here. Okay, onwards we go. So we talked about static blocks. We talked about the access modifier keywords on member fields, which are instance fields, and on static fields. You can see now I can't just call car.generate serial number from the outside anymore. That is private. Even subclasses won't be able to get that. They'll be able to access their own serial number because there's that getter, but they won't be able to generate a serial number. That happens in the base class and stays there. All right. JavaScript private fields. So the access modifier keywords like private and protected predate actual private fields that landed in JavaScript relatively recently. And in the spirit of continuing to evolve our example, let's take our serial number field and make it, instead of like Typescript private, which is just like the honor system, let's make it actually private. So we're going to go up here, and I can get rid of my underscore here because it doesn't really matter. Like, I don't need an indication of what this should be. I'm just going to literally change its name to begin with a hashtag. And that denotes that this is a private field. I'm getting yelled at by Typescript because it's like, this is private. This is private. You don't need to tell me. Like, it supersedes the honor system here. This is actually difficult to access at runtime. And here you can see we have access to hashtag serial number, but we won't be able to access it from outside the class like this. Right? There's my car. This is not accessible outside the class. And this will match, like if you were to open up Chrome DevTools or attach a debugger to a running Node program, you would see that this is for sure private. Now, it's private in terms of encapsulation, but you should remember, if you attach a debugger to, like, if your code is running somewhere that users have access to, they can attach a debugger and they can view this field. Don't put anything here that's like actually a secret. It's not private in that sense. Chrome DevTools has an API that you can use to just grab private fields. It's not secure. It's just private. All right, we could use this for static fields as well. I'm just going to go up top and make the modification similarly. So we're going to take the private static fields, get rid of this, and do this. And we need to update this and this. And we should be good. Oh, one more. See, I should have used the F2 to rename, and it would have taken care of everything. All right, so now we have legitimately actually private static fields, static methods. They cannot be accessed. Even once this compiles to JavaScript, they are still private, as opposed to this, which is just, it'll compile away, and the getter will be there for all to see and all to access. It's important when you think about libraries in particular, because people can just ignore that type and just call the getter anyway, and they'll get the value, right? And they'll depend on that. It's not really a security issue. It's more like they will start to depend on that thing, and now, they'll break if that thing ever changes. So we talked about static fields. Great. OK, this is really cool. Private field presence checks. So we're going to take advantage of something really cool here about private fields. So I'm going to grab this equals method. We'll drop it into the class, and then we'll talk about it. OK, so we've defined a method called equals. And the purpose of this is we want to see whether, I obtain a car. I want to see if I am equal to this other car. Now, we could do it with an instance of. We could do it with, checking for properties, like say, does my structure look like it's a car? But we're going to take advantage of something else. We're going to take advantage of this private field presence check. What this means is if we are given, if other passed to us is of type car, we're able to access it. So this is important in terms of understanding how private fields work. It's not that this instance can see that instance's private data. It's that all instances of car can see private data on all other instances. So here, through type guards, we first say, all right, if this value passed to us, we can start with this, just to not throw you for a loop with unknown. If it is truthy, meaning it's not null, it's undefined, and it is an object type, well, now we know it could have properties on it. And so what we can do then is a private field presence check where we say, is serial number in other? And if it is, guess what we know? It's a car. The very fact that we're able to determine that that field is there and it's a private field, the only way we'd be able to do that is if it's another instance of the same class. So we know for sure that this is a car. Otherwise, we would not be able to, we wouldn't be allowed to even know if a serial number exists. You could have another class like computer, class called computer. Computers have serial numbers too, but you wouldn't be able to see this. You wouldn't be able to ascertain whether that serial number that you're looking for, see, car dot hashtag serial number. It's the one that you have. It's the field on your class, not just the name serial number, but specifically a field that you can access. The fact that you can see that means this is for sure a car. And that's why this guard here takes you from any straight to car. And now for our equality check, we can actually compare serial numbers and we can see, am I a car? Are you a car? So this teaches us a couple things. One is that if we're given a reference to another car, we can see all of the private fields on that thing. It's not a little bubble around each instance. It's kind of a bubble that all instances share. And within that bubble, they can access each other's private data, as long as they have references to each other so they can reach for it. So that's how you want to think about this. And then finally, this private field presence check. We talked a little bit about type guards. This is a prime type guard. We'll talk more in the next chapter about user-defined type guards where you can write your own. This is one of the most solid ones, but it is a little bit nominal type system-ish because it's legitimately checking, are you an instance of car? That's the only way you'd be able to see that private field. Dimitar, I think I answered your question just now. If another object has a serial number too, and I'm going to assume you mean like an instance of a different class has hashtag serial number, that is a different serial number. Like if we had this. Right? When you get to this check, inside this instance of car, you're not allowed to read this, you're not allowed to know it exists. So this condition here would fail. And the fact that it passes, it means not only is there a private field with this name, but is it specifically the private field that you can access? And that's how we know it must be a car. Hopefully that makes sense. It's a pretty powerful idea though. It also makes private fields like much more useful because you can share data amongst each other. If you couldn't do that, it would be kind of very limited in terms of usefulness. All right, one more access modifier keyword here. We've used it already. It's called read-only. We can make this change really quick, but we could make that serial number a read-only field. So now it's a private field that is set when it's initialized, and we cannot change it after it is set. Remember, this is also a TypeScript construct. At runtime, if you had misbehaving code that casts this to another type, they will be able to write to this. That's bad TypeScript code if it's like casting away read-only. So it's just an expression of what you want this to be used for. Actually, in this case, since you can't access this from the outside world, you could be pretty confident that no one would be able to change this.
Going forward, I'll have to avoid typecasting when I'm working, right? Because typecasting actually does not do justice to the TypeScript system. Avoid casting. Have a strict setup. Basically, and don't cast.
You could have a method in here that changes it, but you're trolling yourself at that point. Yep, someone caught a bug. Should be triple equals. And guess what? The read-only just caught that. We'll pretend I left that in there as a bug so that when I added that step, it worked out perfectly.
Yeah. What is the difference between a private and a protected interesting. What does the hashtag prefix indicate for a class field in TypeScript? Means it's private. It's a comment indicator. No, it defines a read-only property. It creates a truly private field that cannot be accessed outside the class. Yes. What is the difference between private and protected access modifier in TypeScript? Private fields can be accessed globally. No. Private fields can only be accessed within the same class, while protected field can only be accessed can be accessed by subclasses. Yes. Private fields can only be accessed within the same class, but protected field can be accessed by subclass. Yes. Yes. Only in that class can you access private. Yes. But it's become accessible when it's protected. That field is exposed to subclasses when it's protected. What does private field presence check allow you to do in TypeScript? What does private field presence check allow you to do in TypeScript? Hide all class properties from external access. Create a new private field dynamically. Yes, it can help you verify if an object is an instance of a specific class by checking its private field. Yes, that's true. What is the purpose of the read-only modifier in TypeScript? Prevent typecasting of a property create a field that can only be set during initialization and cannot be changed afterwards. That's my answer. How do private fields work across different instances of the same class in TypeScript? How do private fields work across different instances of the same class in TypeScript? Only the first instance, no. All instances of a class can access private fields of other instances of the same class. I think that should likely the answer. Yeah, I got 100% this time.
I promised you at the beginning that we would have a way to take that very wordy way of, having all these different class fields, right? Remember we had like make, model, and year, each written 4 times. The answer here is something called param properties. And I'll show you a freestanding example because the car class up top is getting a little big and cumbersome and complicated. I have a make property here, and you have to imagine you can add model and year here. But this is interesting. You have the word public here in an arguments list. Seems weird. You can't do this with functions. You can't do this with methods. Only with a constructor signature. And what this is syntactic sugar for is, actually the easiest way for me to cover this is, let me go to the example and jump to the TypeScript playground here. And we can see the compiled output really quick. So here's public make, model, and year. Here's the JavaScript. This dot make equals make. This dot model equals model. This dot year equals year. So what it's doing is it's creating class fields, make, model, and year, of the correct types, of identical names of these parameters here. And then it's doing
This actually make sense. Oh, I see. This is the TypeScript, and this is the JavaScript equivalent of it. Yeah, makes sense. Good stuff.
the assignment of the constructor args to those class fields, right? So it's taking these.
So what if we do private? Does it work if we do private? No. What if we do private? Will this still work? Or is it only public? Will this still work? Still the same thing, but it can no longer be what do we call it in JavaScript? It can no longer be reassigned. Yeah, because it's a private field. So it's only accessible within the car. Type car. Yeah, makes sense. I think I get
active fields. And of course, it's also setting up the appropriate types on those fields. So if we look back, in here, we can do this.make, and something's there. And its value has been set. So this is the abbreviated syntax. We can go back up to the complicated example here. We could delete this. We could delete this. And we could just here.
public.
Right, public. We'll just auto format there. And there you go. That's our constructor. It does exactly what the old constructor did. Just much more abbreviated syntax because this is such a common thing. And to have class fields and constructor parameters of the same names and that assignment is such a common thing that it's worth it to have some special syntax for it, just to reduce the noise in every kind of class that you might have. I see a question in the chat that I want to address real quick. It's about this static block, which we dealt with a little while ago. So the question from Alexandros is, you can't really use this class until the static block completes. How would you ensure that new is not called before the block completes? Honestly, what I do is something like this. And then I would, before invoking the constructor, I would check to see if the class is ready, or I might wait for this to indicate that it's ready before I booted my application and started calling in code that might instantiate cars. but you do need a piece of data there that lets you have some signal as to whether the data has landed and whether this initialization has completed. You do that is work you have to do there. Only if you're doing async stuff in your static blocks. Sorry for the little tangent there, but I think that's worth looping back for.
Nice.
All right, keep going onward. Overrides. So this just recently landed in TypeScript. I think it's a TypeScript 5 feature here. And I'm going to first illustrate the need for this with an example. So if you remember, we had a class car. Car has does it have a honk property? Yep, there's the honk property.
Yeah.
And so if we go down, like, we have added an extra O in here. We've misspelled this method name. And, you know, this is a truck. It's honking in all caps because it's a truck. And not much is helping us here. I think this is just a spelling error. So this is TypeScript's not helping us at all here. And so if we do this, we instantiate this truck, we're going to get the honk method on the base class. Oh, I got a honk for 5 seconds or something. So the problem here is this is very common. Long method names, misspellings happen. The only thing that's even remotely catching this is like a spell checker. And if I just had like, you know, a word here, a misspelling that happened to be a word, I'd have nothing warning me of the situation. So TypeScript introduces a keyword here called override. Override is it is you expressing the intent that this should override a base class method. And thus, a base class method must exist of the same name. And here we go. Member cannot have an override modifier because it's not declared in the base class. Did you mean honk? If I delete this, that works, or should. Sorry, I have to take in something like that. That what the problem was? Oh, I have to return beep. My bad. There, now it's happy. So override is great. It helps like keep that linkage in place. The thing you'd watch out for if you didn't have this, of course, is you're not really overriding the base method, and so your custom code for your subclass is not being run at all. There's another problem that this helps with, and that is if the base method's name is changed. So if we go up here, we were like, I really want honk there. We should see, yeah, we see an indication that like, all right, my subclasses are lighting up. That linkage, that refactoring is not complete, and you know it's going to tell me that I need to take care of that. Now, what happens if you're not super vigilant here? Well, sometimes you forget to put the override. I mean, it'd be easy to forget. Especially like, let's say initially there was no honk in car, and then it was added later. What we can do in our TS config is say no implicit override. So I'm going to add that to our notes. Note TS config. Let's add no implicit override true. Save. And what happens here is if we're lucky enough to not make the typo, we're prompted to add the override modifier. We're told, hook this up. It's useful. It's here to help you. It doesn't let you override unless you use the keyword, which is a great way to ensure that it's like consistently used. Now you can always, you know, fat finger a method name from the start, and it's tough to help you there. Like there's nothing TypeScript can do to understand whether that was your intent, or maybe you did want a method with a different name. But once you get this right, you can kind of establish it, and this will catch a lot of the other places. This is an amazing tool to help with refactoring, to make refactoring a lot easier.
No implicit override, we set to true. Find type definition for file mini match. That was the TypeScript. That was just a TypeScript. Yep. Now, what is the parameter property? What is the purpose of parameter properties? In TypeScript, we define private class methods to automatically create class feed and assign constructor arguments with the consigned syntax. That's like it. That's it. What does the override keyword do in TypeScript? Ensures a method in a subclass actually exists in the base. Actually, that's true. That's what override does. That's function override in a class. How can param properties be defined in a constructor? By using the type annotation with access modifier. Yep. Yes. By adding public. What configuration option helps enforce consistent? No implicit override. That's it. What does param properties automatically do when used in a constructor? Yeah, this is what it does. I got it, 100%, yes.
So we've got two big topics left in this course. The first is type guards and narrowing, and then we're going to touch on generics as our final topic. Type guards are really important pieces of code where you can think of them as like a junction between something with special meaning to the type system and something equivalent that actually is evaluated at runtime. A great example of this, or several examples, is this here, which we saw before, where we're like, okay, I've got this function that could return some tuples. I'm going to use the first element of the tuple to narrow, right, to handle the error case, and then here's the else down here. When I say that there's something where compile time type checking and runtime evaluation meet, it's really this line right here. This line of code is run. It's part of what your JavaScript program will run. And it also has meaning to the type system. And those two things are in close alignment. This check at runtime will only pass if the first element of the tuple is the string error. And we know that it's safe to narrow down this way if that check passes. There are lots of other built-in type guards that you can use. So here are a variety of them. We've seen this one, instance of. We've seen this one today, type of. There's a specific value check. We saw this with discriminated unions. Remember when we were checking explicitly if the first element of the tuple is the string success or error, we were able to use that. A truthy-falsy check is a type guard, right? If you have a value that could be undefined, it can become defined. There's a built-in array function called isArray, property presence check, right? This is just seeing if value has date range in it. And I think that's the full list. Now, let's go through, let's look at this. We've got this value, which could be a date, null, undefined, the string pineapple, a tuple of size 1 containing a number, or this object containing a date range with paired dates. So this is one big conditional here, and we can see how we use these type guards to narrow down into specific little cases where we know we can handle this value in a specific way, depending on the type guard that's applied. Here, instance of date, we narrow down to date. Here we're checking to see if the value is a string, and we know pineapple is the only possibility that this thing could be. That's the only option here that's a string. Here's the specific value check. We're checking to see if it equals the value null. Null is the only thing it could be, so we're crossing these off the list effectively. Now we can apply a truthy-falsy check, and it could have been null, but we handled that up here already, and we're in the else block.
Let's go to let's go here and check that clean. Checking that clean. Now Okay, type guards, when used with control flow, allows TypeScript developers to create branches of code that have concrete assumptions of what may be a relatively vague type. Concrete assumption of what may be a relatively vague type. One example we've already worked with is the concept of discriminated union, where we took a value that could indicate either success or failure information, and used an equality check with the discriminator, okay, to send the successful case down one code branch and the failing case down another. So we have, for example, let's say, let's try it. So what we're saying is, I see. Yeah, let's go and break for 10 minutes. That's for 15 minutes. Nice. I'm just motivated to continue, right? Could just use that. I'm looking at type guards. Okay, so it will be good for us to look at the code. Okay, it returns. Script. But what we're saying is this a type? Interface error. So let me just const. makes some sense. The return type is an array. Nice. I think I understand it. The constructing it this way makes it stick. Okay. Type guard. Nice. 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 Oh, I see. I see. I see. Makes sense. Once you see this, then it's a type card. Okay. Okay. Type card. Okay, makes sense. Makes sense. Makes sense.
So we know that it's not null. It has to be undefined. If it's still falsy, it must be undefined. We can check to see if it's an array, and then we get that tuple. We can check to see if it's an object with, I mean, actually, by this point, this is the only thing it could be, right? So we're checking to see if date range is in the object, and it is. And down at the end here, we get this thing called never. Remember, that's the type, call it a bottom type. It represents the empty set. What this means is we're all finished. There's nothing else it could be. We've handled every possible thing it could be using these type guards. And within each of these code branches, we have a very specific type that we can act on. We can define our own type guards. So let me go back to our code here real quick. There are the built-in type guards. Here are our user-defined type guards. So let's say that we have this interface car-like, something car-ish, and we have this value, which is an any, could be anything, right? We want to determine whether it's a car, and we want to do that just exclusively based on shape. So what this would do, like it's very verbose here. We're going to work our way towards things that are a lot more sane than this. We first have to see, like, okay, is this truthy or not? Like, is it null? Is it undefined? All right, we check to see if it's an object. We check to see if make is a property in the object, and the value of make is a string. And we do the same thing for the other fields. And then when we get down here, we get nothing. Doesn't seem to be working for us. And but this is what you would have that represents this check. Part of the challenge here is there's so much going on here, and we start with an any. You know, it's just not able to narrow it down. So what we can do instead, we need this user-defined type guard. We can define this function that says is car like, and we put that same check in here. And what we would hope is when we're done, we can write something like this, where we'd say if is car like, and then we'd get the type car in here. Now we don't have it yet, but this is the syntax we'd like. Maybe we define this in one place, and then we can use this nice readable like JavaScript, Typescript everywhere else in our app. So we're going to have to alter our function signature slightly by adding the following return type: value to test is car like. Now looking at this, what is the actual return type here? Like, forget what I just wrote. What's the type of thing I'm returning? It's Boolean. You're absolutely right. It is a Boolean. Type guards should return Booleans. They need this tells the compiler what the Boolean means. If the Boolean is true, it means value to test is a car-like. If the Boolean returns false, it means it's not a car-like. And that's what lets us have a user-defined type guard here. It's not just about returning a Boolean. It's about this line of code here, this expression that tells the compiler what the Boolean means. It's what connects this stuff that runs at runtime with what it means and what we should take it to mean at build time. And it's very important that you keep these things well aligned when you write user-defined type guards. If you write these poorly, if you write type guards that lie to you, the lies will be very confident, and you'll have weird stuff popping up throughout your application. So it's very, very important that you kind of keep this well aligned with this. And as long as you do that, these things are great. They help you handle union types beautifully. it's common to use these for like API responses that you've received, and you don't know what this JSON thing is, but you pass it through one of these, and then you get a great type that you can send, downstream to the rest of your code, and it's like a very nice typed response, but it has to be consistent. The runtime and the meaning of the check have to be in close alignment. So that is a type guard of the value is foo form. There's another thing we can write here, slightly different. Oops, did I just, yeah. I'm going to get rid of the bottom thing. Okay, this is a different flavor of type guard, and I want you to look at this return type here. It still returns a Boolean. We've inverted it. There's that bang and parentheses around it, so we flipped it. And we're saying, if it turns out to not be car-like, throw an error. Now we can say, asserts is car-like, and we say this. It asserts that value to test is car-like. And instead of having to use it in a condition like this, we can use it like this, where like, effectively it's the same concept, except we're saying, look, it's not about if else, it's about throw versus not throw. Like the fact that we made it to the next line, the fact that we're on line 114 and haven't thrown, that means it's a car-like. Whereas up here, it was an any. These are also good. It just depends on what you're doing, whether you want to throw or not, right? I would use these when you intend to throw, when you should throw. All right, we're going to come back full circle to classes right now. So remember our private field presence check, right? We use that to make our equals method. Well, I mean, remember how nice this was? When we the fact that we can see this field here means it's definitely a car. Right up until this point, it was an any, but getting past this one check told us that it's a car. I love static methods as user-defined type guards here, because it can see private data, and this is a pretty bulletproof thing. I mean, just consider how good that looks versus this. Now, they're not equivalent because this kind of type guard is much more conducive to like a structural type system where you're really just dealing with issues relating to shape. Not issues relating to which constructor you came out of. Sometimes this is what you want. Sometimes you want nominal style type guards, and this will work beautifully. I would just recognize which each one is. They're both tools in the toolbox, and this one is really nice. So I've just taken our .equals method and removed the comparison of serial numbers, and I just returned true if we make it this far. That's all I did here. But the presence of a private field, it is conclusive. The fact that you can see it at all means you know what this thing is. You could do this, and then, maybe if instead of returning false down here, maybe you kick out and you check some structural things. You've got options, but they're both kind of good tools. Oh, and you can see proof that it works, although, well, there's car, there's any. But static methods are pretty good with that. This is something that was added pretty recently, I think it's a 5.3 feature. The ability to narrow with switch true. So I've created two classes here, a fish and a bird. Fish can swim, birds can fly. And I can write a nice little switch statement like this, which some of you that come from other programming languages, this is a very common construct to see. If you've ever heard the term pattern matching, this looks a lot like pattern matching, right? If you've used Scala or Erlang or Elixir, there are lots of languages that have pattern matching like this. So effectively we're saying, I'm going to switch on true, but really it just comes to each case clause being compared with true. So we're going to keep going down these case clauses until we find one that evaluates to true. And so here, oh, did this work? Val, instance of bird. Wait a sec. I suspect I know what's going on here. Yep. It's definitely a 5.3 feature because it's not working in 5.2.2. Here's 5.3. Hey, there we go. Super modern. VS Code likes to troll me by switching which TypeScript version it uses without telling me. So, but this looks very neat, especially if you have a long chain of things that you're trying to process. It's nice to have an option to write things this way. So my advice for writing high-quality type guards, I talked about this a little already, but here's an especially bad one here. We're writing a type guard that's supposed to check if val is specifically the value null, and we're writing it as if null is the only falsy thing that could exist. The number 0 will pass through here, an empty string will pass through here, the Boolean false will pass through here, undefined. It's just, these are all really bad. These are bad. We would fix it by saying val, something like that. This would be a silly type guard to write because you have a built-in one, this right here, but this is a particularly harmful place to lie in your types, because TypeScript will take you at your word, and it will trickle all throughout your code. You'll think that I sold you a bill of goods, that I told you that this will help catch bugs, and instead it's creating bugs, so be careful in this area.
What are type guards primarily used for in TypeScript? To define class instance, to define class inheritance, no. To narrow down types at runtime and at compile time, yes. So there are two sides to it, build time and at also runtime. Which of the following is not a built-in type guard in TypeScript? It's object. This object is not. What is the return type of user-defined type guard function? It's always a boolean. It's always a boolean. What does a never type represent? Can it be? I think it's a null value actually. Empty set actually. What is a key recommendation when creating type guard? Avoid using static methods. Yes, this is advice. Keep it well aligned. Nice.
The last topic we're going to cover in this course is generics. This is really getting to the end of fundamentals and sort of tipping your toe into the intermediate level. And if you want to go deeper than this, check out the intermediate TypeScript course. We pick up right where we leave off here, and we start working with generics and talking about more interesting and powerful things that layer on top of it. Generics let us parameterize types, and it allows us to create more reusable types that can be expressed in terms of type parameters. So let's talk about a motivating use case, because I don't want to just throw abstract stuff at you and tell you that it works this particular way. Like let's ground this in a story. So I'm back to my contact information app. I want to store phone numbers, right? And I have an index signature here. So in my dictionary of phone numbers, each value has a customer ID, an area code, and a num. This is a number, phone number. And we can see that I can hang whatever I want off of this thing, and they all have the same type. Here you go. All have the same type. I'm gonna switch to my code. Actually, you can follow along on the website, but it's the same stuff. So let's say I had a list of these phone numbers here, right? And I want to create a dictionary of them. I have something like this, and I want to end up with something like this. And I'll tell you where we're going to go here. I'm not M. Night Shyamalan here, so I'm not trying to throw a crazy twist at you. We're going to solve this problem specifically, and then we're going to widen it out and end up with a generic solution that'll allow us to go from a data structure like this to one like this. In the general case, phone numbers, anything else. So first off, we're going to create an interface representing phone info. Same type of object that we were seeing in that index signature before. And what we want in the end, this is just the type of the function. We're kind of just stating what we're taking in as an argument, and what we're returning at the end of the function. In fact, I can implement this really quickly. Done. All right, let's go home. No, we still have a lot of work to do. In particular, we need to provide this third thing. It's a function that we use to determine the ID of each object. So if we look at this, we need to figure out this here, right? Given one of these, we need to extract out, what's the key I want this stored in the dictionary as? So I'm going to take in a function there because I want my caller to be able to provide me with that information. The caller gives me the list. The caller tells me how each item of the list should be treated, and I'll spit out the dictionary. So the first thing we need in our function body here is to initialize a data structure of the right type. We can return it at the end. And we want to loop through every element of the array, right? So this is the list of phone numbers. For each of them, we're going to take this element, which is a phone info, right? So it's just one of these. And we're going to get the key from it, the dictionary key. I'm going to invoke the callback that I'm provided with. Remember, it's the caller's responsibility to tell me each member of the array, how do I obtain an ID from that member of the array? And so it's going to generate an ID, it's going to take a phone info in, and it's going to return a string. So that's my dictionary key. Then I'm going to take my dictionary, and under the key, I'm going to store the element. Everyone following so far?
That makes sense.
Good.
That makes sense.
Okay. And this is what we're going to get as the output. So we would get this result out. And this will work. If we were to run this code, it would work. But it's not very generalized. There's phone info all over the place. What if we wanted this to work in a way where we could do an array of dates, or we could do an array of, I don't know, payments, each of which has an ID, something like that. And we want the ability to say, here's a list, transform it into a dictionary for me. So if we want to generalize this, we're going to have to change the function signature a little bit. And let's start by making it more flexible. So to make it more flexible, I need to be able to return a list of anything. I could do this. Great. Now it works with whatever I need it to work with. I mean, is anyone happy with this? Are these some great types that we've written out here? Not really. Any is all over the place. We have flexibility now. We needed to sort of broaden what we tolerate as inputs, but we've lost all that great type information. So what we need to do is define a type parameter. I'll uncomment these so you can see the little clues that I'm reading as I go along. I already know how to do this one here, but like we're going to define a type parameter, and we're going to start writing it this way. So this, you can almost think of this as like another arguments list for types. So I could do something like that. It's just like an arguments list for a function. In case you're wondering, like you might see T all over the place for generics. You can trace that back to, I think they're called like, gotta think back to my C++ days, template classes, T for template classes. So it's just a cargo cult, like a convention that people stick to. You can make this whenever you want. You can make it many letters, whatever you want. The convention though, like capital, helps disambiguate between like function arguments, which would start with lowercase. Okay, so we have this type T. And we're gonna say we take in an array of T's. And we're gonna say our ID generation function takes in a T and returns a string. And ultimately what our function is gonna return is a dictionary of T's. Sorry, this isn't in any array, this should be just a T. All right, T for everyone. So, okay, now this is starting to look interesting. Let's see what our function invocation looks like. Okay, that's something. Notice how this is between the angle brackets there. Our type param has been inferred, meaning we passed in this phone list thing, and we knew we're taking in an array of T's. So you can think of it as like the type param is figured out for you behind the scenes by Typescript based on what you're passing into the function. So you don't often need to explicitly state your type params. Sometimes you do in cases where it can't be inferred, but in a lot of cases, you might be benefiting from generics, from type parameters, without even knowing it. That's kind of the best type of generics, where like engaging with them is simple. You don't even know they're helping you, but you get all this great type information coming out the other end. Look at our result. It's a dictionary of these objects here, of our like phone info objects. And we get type checking in our little callback here, because we take in an argument of type T, and here it is. So if we were to look at the type of that argument, look at that. Here it is. Here's the arg. Here's the return value. So we get type checking all the way through. This is a type param. That's what's working for us here. So let's take a little bit of a step back and look at a simpler example, just so we can wrap our heads around this. Let's define a much simpler typed function, and we'll call this wrap in array. So this function just takes in an argument and returns it in a tuple of size 1. That's all it does. This is it. That's the whole story. So if we say wrap in array 3, well look, we pass in a number, and it's figured out what T should be. And it returns this, a tuple of size 1 with a number in it. If we do the same thing with date, figures that out. Like auto-setting T for us behind the scenes. We do it for a regex. Look at that. So we get this flexibility, the same flexibility we got with any, but we're not losing
Type.
specificity. We're not losing all of that type information by calling this function and getting a bunch of any's coming out. We get to keep that. Let's see, can I do that? Wrap in array? Oh, I would have to do this. All right, it's all in there. There's my exec method, which is on regex. So all of the type information is flowing through.
Nice. 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 I'm through with this course. So good. Generics. Makes sense. We got generics very well. lists that it is equals to that's right. List, which is its type. No, argument that it takes will be a type generic, right? And this it resolves to a string, right? What's the function? And what's the return type? The return type is of index signature that we have studied before. String, out of string, at the same time. That makes sense. Makes sense. Makes sense. concept stick a bit more. Cross, that's like, because you can see, I'm saying that this sort string which we no. Oh, what am I able to do? On the list, what does the list contain? The list contain you don't need it. Okay. Okay. I can see that date element close key equals to nice. All right. Okay.